Solving today is called tree sum. It's a medium difficulty question. So basically what we have to do is that we'll be given an array of numbers, and there are actually a list of triplets that we need to obtain from this list of numbers that sums up to 0, and we're not supposed to contain any duplicates in the output. So the first example, we can see that given this list of numbers, the triplets that sums up to 0 is -1, -1, and 2, and next one is -1, 0, and 1, right? So one way we can solve this is basically the most straightforward way. It's basically using the brute force approach. So go through an idea. So solution 1. Brute force. Okay. So in this solution, what you would do is you have this list of numbers. You would declare a variable I that starts at the very first position, that goes all the way to the third last number from the back, and you start another variable j at the next variable after I, goes all the way to the second last number, and you do the same thing with k that spans the one element to the right of j that goes all the way to the end. And at each point, you grab one number from I, you grab one number from j, and you grab one number from k. So the first iteration in this approach, you would have -1, 0, and then you would have 1. And this will continue on all the way for k, for j, and for I. This is not a very optimal solution because you would actually have to go through the list of numbers, all the elements, close to all the elements, 3 times, right? So this will actually have the time complexity of O to the power of n to the power of 3. So this is not really optimal, but it will get the job done, right? So basically, when the next iteration happens, j will simply move to the next value, and the same thing will happen to k, right? But then k will actually go forward first. So you have -1, 0, and 1, and k will first move forward, and then you would have in the next iteration, you would test for this number. You have -1, 0, and then 2. So basically, grab I, grab j, grab k, and then you continue all the way till k runs out. And when when k runs out, j will then move forward. And when j runs out of elements, I will move forward, and all of them will continue the same process. So this is a very slow algorithm to solve this problem. So we can actually just code that out first. So show 1, which is basically brute force approach, right? Okay. So we can just say get tree sum brute force approach. Fill list of numbers. Okay, so what you do here is that you would actually have a set that contains all the triplets that you want to give as output, so there will be no duplicates in output whenever it sums up to 0 for that number. So you go through all the variables. You start with having a set, and then you go through each and every single number. Length of nums -2, because the first I only needs to go to the third last element, because anything beyond that, there will be no more triplets left. Next you have this, which starts from I plus 1 to the length of nums minus 1 now. And same thing for k. You will have j plus 1 next to j. K starts from next to j, and you go nums all the way to the end, right? And you continue this process for all the numbers. So you can say the total value of all these 3 numbers is actually nums at position I plus nums at position j and nums at position k. This will give you 3 values, right? And also you can create a triplet for the 3 of them together as basically a tuple. So j and then k, right? So first step you have to do to this is that first you can put them in an array and you can sort them, right? So because if this is not sorted, you will have a problem of identifying duplicate. So you can sort it first, and then after that putting it back into a tuple so that later you can add it into the set, right? Because in sets you can actually process the uniqueness of an array. So next step is to check if the value is the same. So if the total value equals to 0, which is the question asking you to return triplets that sums up to 0, what you would do is you would simply add this triplet to the output, right? So you just continue the whole process, and when you're done, you have all the output of triplets. So you can just simply return output, and you can test this out. So now we'll just simply print the output of this, and grab this input, paste it here, and we can double check. We run Python trees. So you can see that we have the correct output, -1, -1 and 2, -1, 0 and 1, right? So there are actually 2 unique triplets. But this approach is not yet the best solution to this question, because this runs in a time complexity of n to the power of 3, space complexity of basically n, where n is the number of triplets. Okay, so another solution is that we can actually make use of some properties of the array in a certain manner. So one way is we can actually first sort this array. So we have solution 2 here, which is the 2 corners approach. And you'll see why this one is more effective later. So first you have the same input, right? What you would do is first you will sort it. So first step is to sort the array. So when you sort the array, you will get -4, and then -1 here. You'll get 0. You'll get, I think, 2. Sorry, you get 1 and then 2. Right, so you'll have -4, -1, -1, 0, 1, and 2. So when you sort an array, the time complexity you have taken into consideration is n log n. So once that's done, what you would do is you have a variable I that starts at the first index of the array, and you will also initialize 2 pointers. One pointer is called L for left, so basically L just represents the left pointer, and R represents the right pointer. Okay, so you will start the right pointer all the way to the end of the array. So what you would do is at each point you pick one number from I, L, and R. So basically, in this case, you would have -4, -1, and then you have 2. So you can see that this will give you the sum of -5 plus 2, so you have -3, which is not equal to 0, right? So what you do now is very important. When it's -3 is very far away from 0. To get closer from -3 to 0, you have to move the left pointer to the right. Okay? You can't move the right pointer to the left because that would actually decrease the value and you'll be further away from 0. So what you want to do is get closer to 0. So to get closer to 0, you have to increase the sum, and in order for you to increase the sum, you have to move the left pointer. So now when you move the left pointer, this is still the same, but if you hit a 0 now, the sum value would actually increase, right? Because let's say the second value represents the L value. So when L is 0, you will have -4 plus 2. This will actually become -2. So you're actually getting closer each time you move the left pointer by increasing the value. So next you'll move to actually 1, where this will simply be -1 instead, right? Because it will be -4 plus 3, and it would be -1. So when you reach a point where the left and right pointer are the same position, basically taking up the same element, or they exit one another, like the left element moves past the right element, you will actually stop and you will proceed on to test the next iteration of the I variable. So you move I, and L will just simply start next to I, and you continue this whole process of finding out what are the different triplets you can obtain that sums up to 0. And why is this more efficient? Is because if you think about it, at every single iteration of I, you only have to check the remaining pairs for the elements that are remaining ones. So this brings us to the complexity of O to the power of n instead of n to the power of 3, right? Because at each point of one variable, j have to go through one whole loop past the entire list of remaining elements, and so does k. But at this iteration of I over here, L and R basically goes through the same remaining elements left, right? You're just manipulating whether or not you would move left or would you move right, right? If the sum is actually smaller than 0, what you would do is you would move the left pointer, and when sum is actually greater than 0, you would actually move the right pointer down, because this is sorted. Moving R would decrease the sum, moving L would actually increase the sum, and that's how you actually get to the target value of 0 more optimally. So we can actually write a code for this solution now, and later we'll print out a number of operations that these two algorithms perform, and you can see the difference in the number of times it takes for you to find the same solution. Solution 2 is the two pointers approach. So we'll copy this method, and we'll just say taking in the same sum, you have the same output. Sorry, it's supposed to be a set. And next you would actually first sort this element. And once this element is sorted, you can perform the iteration of I across all the numbers. So same thing, you do not need to check the last two elements because it'll be taken up by left and right pointer later. So at every stage you initialize a left pointer, which starts at I plus 1, and you have a right pointer that starts at the last element of the array -1. And what you would do now is you would try to find the sum of these three elements together. So the value is basically your sums I plus sums of the left pointer value. So what you do now is if the total value is equal to 0, meaning that you have found a match, what you would do is add it to the output. So output.add, and you would give it nums I, nums j, and then nums k, which, sorry, this should be the left pointer, and this should be the right pointer, and there you have it. Else if the total value is actually lesser than 0, meaning you have to increase the sum, what you would do is you move the left pointer. So you move the left pointer outwards, so you add 1, and the last scenario is when the total value is greater than 0 and you move the right pointer to the left by deducting 1 from the value of the right pointer, right? And one thing to note is that over here we'll also need a while loop, right? So while the left pointer is lesser than the right pointer, you would continue to process what's left in this whole series of elements that you have iterated through. And when the value of the left and right pointer is actually equal to one another, you will then move the left pointer and also move the right pointer, right? So once that's done, you will be able to return the output. So let's comment this part out first so we don't get confused. Okay, so now what you have here is all the solution. Get tree sum, giving it the same value of nums over here, and you're trying to print it. So you can see that they actually return the same thing. So basically, you get to the same output, right? So now we'll compare the number of operations that this performs. So as we have said, that this time complexity is O to the power of n to the power of n to the power of 2, and space is the same. Basically, n just represents the number of triplets. And now you can check the number of operations, right? So let's try, right? So operations performed. So that's at 0, and each time you iterate through this, we can increment operations, and you can actually just simply print out the number of operations that will actually check over here. So you can just do a print statement, I guess. Just print this out. Operations. So just make this into a string, so we have no issues. Okay, and you do the same thing. The code over here, right? Okay. So comment this two part out. Operations is 0, and then we will increment the operations over here. Okay. What you do now is you print the number of operations that this will perform. Now when you run these two operations together, you can clearly tell the difference, right? So this is actually solution 1, and that is actually solution 2. So you can just print this out. Basically, why not you just print out the final number of operations on above here instead of this. So now you have two operations competing with one another, and you can also do a print that this is the solution to the two pointers approach. And the bottom one is the brute force approach. Okay, so now that you have these two things together, you can actually just run these two things together. And you can see that solution 2, which is two pointers approach, actually only need 9 operations to find the two sets of triplets, where the brute force approach actually perform 20 times in terms of operations in order to get the same value, which brings us to the point of n to the power of 3. As you can see that we have about 6 digits where it represents the n, and yeah, it takes about 20 operations in order for you to achieve the value that you need to find. Whereas for this case, it's actually only 9 operations from 6 values, so it's very close to the number of elements that you have to find in terms of operations. And yeah, this is how you solve the tree sum approach. Thank you.